video is on mixed numerals and improper fractions. Now, when we see fractions, we're used to seeing fractions where the numerator is smaller than the denominator, say like 1/3. But what happens, that's called a proper fraction. But what happens when we have a fraction like this one, 3/2, where the numerator is actually bigger than the denominator? Let's have a look. If I draw a diagram, there's a circle, and I'll draw 1, 2 halves. I need another half, 3 out of 2. So I'll draw another hole and break it into halves, and there is my third half. So I have 1, 2, 3 halves because each hole is broken into 2 pieces. So another way I can write that, this here is an improper fraction, but I can write that as a mixed numeral. A mixed numeral shows us how many holes we have. So in this case, we have 1 full hole shaded in, and then how many leftover parts there are. In this case, we have 1 hole plus 1 half. So 1½ is the mixed numeral, and 3/2 is our improper fraction. Let's look at going the other way. So if I start with 2 2/5, that's a mixed numeral. I want to write that as an improper fraction. So how many fifths I have in total. So let's start by drawing our 2 holes. 1, 2. Each circle represents 1 hole. So I'll shade in both of those holes completely because I have 2 full holes. I need 2/5 as well. So I'm going to draw a third circle. I don't have an entire 3 holes. I only have part of the third one. I'm going to break that into fifths. 1, 2, 3, 4, 5. I need 2 of those fifths. So there's our diagram of 2 holes and 2 fifths. 2 2/5. Now, if I want to write that as a fraction over 5, I need to work out how many fifths I have. Well, over here I have 2 fifths. What about each of the holes? If I break a hole into fifths, 3, 4, 5, I have 5 fifths for each of them. 1, 2, 3, 4, 5. 5 fifths, 5 fifths, 2 fifths, 5 plus 5 is 10, plus another 2 is 12. So that's actually equal to 12 fifths. Because whatever denominator you're using is how many parts you're breaking each hole into. So each of these holes contains 5 fifths each. Let's do one last example. Let's do 6/2. And let's write it as a mixed numeral, or not as an improper fraction. So let's start by drawing as many halves as we need. We've got 1, 2 halves. And I'm breaking it into 2 because my denominator is 2. I'm going to go down ways this time. There's another 2 halves. So that's a total of 4 halves. I need 6. So 1, 2, 3, 4, 5, 6. If I shade my last 2 halves in, I'll have a total of 6 halves. So that means, how many holes do I have? I have 1, 2, 3 full holes. I have 3 full holes and I've got nothing left over. So I'm actually going to leave that as just the plain number 3. You might notice that I can do 6 divided by 2 and I'll also get 3. And that's because sometimes we can think of fractions as actually dividing. 6 divided by 2 is 3. Over here, 3 divided by 2 was a mixed number. And that's because 2 doesn't go exactly into 3. You can't times 2 by a whole number to get 3. So 2 goes into 3 one whole time, and then it goes in 1 more half of the time. Over here, 5 goes into 12, 5, 10, 2 whole times, and then there's 2 parts left over. So that's why we end up with 2 2/5. So that's how we change between mixed numerals and improper fractions when we have more than 1 whole. We use proper fractions where the numerator is smaller than the denominator, when we don't have quite a whole. We have less than a whole, like a half or a third, and so on.